Good afternoon, everyone. Welcome to AEMO's Quarterly Energy Dynamics Report for Q1 2025. My name is Franca Tamaris, the Events Coordinator at the Melbourne Energy Institute. Before we begin, I'd like to acknowledge that today we are gathered on the lands of the Wurundjeri, Woiwurrung and Boonwurrung people, who have been custodians of this land for thousands of years, and we acknowledge and pay our respects to their elders past and present. I would like to start by apologising for last week's technical failure of our Zoom webinar. It was a university-wide problem that required investigation by our IT people. So thank you to Kerry and Slayman for making themselves available today. Some housekeeping rules before we start. All questions must be submitted through the Q&A option on the menu as a chat function is disabled. We will have some time for questions at the end of the session. We will endeavour to get through as many questions as possible. Now to introduce our speaker today, please welcome Kerry Galloway, Manager Market Insights at the Australian Energy Market Operator. Kerry leads a team responsible for the Quarterly Energy Dynamics Report, a key publication from AEMO. With 20 years of experience in the energy industry, she has worked in various areas of the wholesale and retail gas and electricity markets, including demand forecasting, network planning and connections, and market reform delivery. Kerry holds a Bachelor of Engineering in Mechanical Engineering and a Bachelor of Science in Applied Mathematics from Monash University. And today's moderator is Dr. Slayman Mahana, Senior Research Fellow in Electrical and Electronic Engineering at the University of Melbourne. Thanks again for joining us, and now over to Kerry.
Thank you, and thank you for having me here today to discuss the Quarterly Energy Dynamics, or the QED as we call it, for Q1 2025, which covered the first 3 months of 2025 calendar year. As people probably are aware, the QED provides the detailed overview of the quarterly outcomes for all the markets that AEMO operates, which is shown here. But today I'll be covering the NEM, or National Electricity Market, and the East Coast Gas outcomes, and I'll start with the NEM. So kicking off the NEM, looking at the NEM demand outcomes. So the chart on the left shows the Q1 trends in NEM demand, with the operational demand shown on the bottom here in the purple line, and then the underlying demand in the top on the green line, and the rooftop or the distributed PV output in the yellow in between. So in Q1 2025, the average underlying demand for the NEM reached a new Q1 high. It was up 1.4% from the same quarter the year before. Now, this was really driven, so this growth in demand was mainly driven by warmer temperatures, and they were particularly in Victoria and South Australia over the quarter. And we also saw a record high in rooftop PV output for Q1, and that was an increase of 16% from Q1 2024. And this strong rooftop PV output growth offset the growth in the underlying demand, so that operational demand, which is the demand that is sort of served from the grid, that decreased by 0.8% year on year. And this chart here on the top left shows that impact of the rooftop PV during the daylight hours, where the operational demand, which is in this red dashed line, dropped compared to the previous year in the middle of the day. But outside of the daylight hours, including during the evening peak, the operational demand remained higher than during the year before. And underneath that chart, we show the growth in underlying and operational demand on a regional basis, and that really shows clearly that Victoria and South Australia drove those increases in underlying demand, and again that was because of those warmer temperatures over the quarter. And South Australian underlying demand actually grew by 7.6%, which was an all-time quarterly high for South Australia, and Victorian underlying demand grew by 6.3%, and that was the highest underlying demand for a Q1 since back in 2014. And operational demand was also up in those two regions. But in Queensland, New South Wales and Tasmania, operational demand was actually reduced year on year. I'm just going to take a bit of a closer look at the impact of rooftop PV at the sort of demand extremes. So on the top left here, we have the 30-minute maximum operational demand trends for quarter ones. And in this quarter, Queensland was the only region to set a new quarter one record. And in fact, it was a new all-time maximum demand record for Queensland. And this was set on 22nd of January. So even though in Queensland, sort of on an average basis, it wasn't that hot over the quarter, they did have some hot days throughout the quarter, particularly in January and Wednesday. Oh, sorry. Oh, anyhow, that should say January. Wednesday, 22nd of January. Sorry about that. So on the top right, we have the maximum demand profile for Wednesday, the 22nd of January, and Queensland's operational demand actually peaked at 12,335 megawatts at 1600 hours. But at that time, operational demand was actually 22% lower due to the rooftop PV generation, and operational demand didn't peak until 2 hours later at 1800 hours. And underneath that chart, we show the demand profile for Wednesday, 12th of February, which was South Australia's maximum demand day for the quarter. Now, this wasn't actually a new quarter one record for South Australia, but it was only 81 megawatts under the current record, which was set back in 2011. So again, South Australia's underlying demand peaked at 3,594 megawatts at 1730, and at that time operational demand was actually 17% lower due to the rooftop PV output. And then the operational demand peaked at 1.5 hours later. So this is really just to show how the rooftop PV impacts the shape of the operational demand, both reducing the sort of maximum level that needs to be served from the grid and shifting it later in the day. And now I'll just move to the other extreme of the demand scale, which is the minimum demand. So this chart on the bottom left shows the 30-minute minimum demand trends for quarter ones. And in quarter one 2025, we recorded new all-time minimum demand records for New South Wales and Victoria, as well as quarter one records for South Australia and the NEM as a whole. Okay. I'll now look at the price outcomes for the quarter. So wholesale spot prices averaged $83 per megawatt hour across all NEM regions in quarter one 2025, which was up 9% from the same quarter last year, but 6% lower than the preceding quarter. So this chart on the left shows the NEM-wide average prices by time of day, and the chart on the right shows the regional quarterly averages for quarter one 2025, quarter four, and then quarter one, both of 2024. So this chart and the table underneath breaks the regional average prices into what we call the energy component, and that's the average of the 5-minute prices capped at $300 per megawatt hour, and the cap return component, which is the average of the 5-minute prices in excess of $300 per megawatt hour. So the sum of those two components equals the average quarterly price. And we use this breakdown to give an indication of like how and where the prices change. So the cap return component provides a measure of the sort of high price volatility. And we can see that in quarter one 2025, this decreased across the board because there were very few high price events, whereas the energy component increased in all regions apart from Queensland. So, the price drivers sort of causing this dynamic were mixed across the region, and they somewhat sort of offset each other. So the higher operational demand that I discussed really did impact the Victorian and South Australian prices. And Victoria's wholesale quarterly average price was up 15% year on year, and South Australia's was up 20% year on year. And combined with that, we had lower coal availability, which led to reduced volumes of coal generation offered in most price bands. So we had around 600 megawatts less volume offered in price bands less than $100 per megawatt hour, and that led to them setting prices at higher levels than during quarter one 2024. And we also had reduced volumes of lower priced hydro generation, particularly in Tasmania and Victoria. And we had around 400 megawatts less volume at prices less than $100 per megawatt hour. And this was really quite impactful in Tasmania, where the quarterly average price increased 67% year on year. And then for downward price pressures, we had increased availability of grid-scale solar and wind generation, which led to them setting prices more frequently, and that increased the number of zero and negative prices, and particularly in the northern regions. And there were also fewer high price volatility events, as I mentioned, when compared with Q1 2024. So overall, this led to New South Wales quarterly average price remaining relatively unchanged year on year. It was up just 1%, and a 24% year on year reduction in the Queensland quarterly average price. So I'm just going to delve a bit more into the price setting dynamics. So the chart on the top shows the price setting frequency of the different fuel types and the average price each fuel type set when marginal, comparing Q1 2025 with Q1 2024. So with those changes in offer volumes in the black coal and hydro that I just mentioned, there was an upward shift in the average prices set when those fuel types were marginal. And that impact was somewhat moderated by a reduction in the price setting frequency. So hydro was the fuel type that set prices most frequently this quarter at 31%, which was down from 35% in Q1 2024. And it saw the highest jump in prices set when marginal, up from $85 to $123 per megawatt hour. And then black coal was the next frequent price setter, setting prices in 30% of intervals, down from 34, with an increase in prices set from 71 to 84. And then on the other hand, grid-scale solar, wind and batteries all saw increases in price setting frequency, with the combined price setting frequency of grid-scale solar and wind increasing from 10% to 15%. Now, the prices set by wind did increase, but still negative and still at the lowest level out of all the fuel types, and the prices set by solar decreased slightly. And the impact of this price setting frequency, the increased price setting frequency, was seen in the occurrence of negative prices increasing in all regions apart from Tasmania. And the frequency of negative or zero prices more than tripled in Queensland and New South Wales from their level a year ago. And the frequency of which battery load set the price also increased, and that was particularly across the daytime hours when the batteries are more likely to be charging, and the frequency of the battery generation setting prices also increased, and that was mainly during the evening peak when the battery generators are more likely to be generating. Okay, so this slide looks at the interregional transfers for the NEM, and the overall trend seen in this quarter was an increase in southward flows and a reduction in northward flows. And this was driven by the increased demand in the southern regions and the relatively lower demand in the northern regions compared to a year ago. And there were also increased transfers from Victoria to South Australia. And we had the first stage of Project Energy Connect being commissioned over the quarter. So for some backgrounds, this first stage of Project Energy Connect, or PEC, is a new transmission line between Bundy in South Australia and Boronga in southwest New South Wales. And it also has a connection to Victoria between Boronga and Redcliffe. And this first stage of the interconnector is represented as a 150 megawatt increase in the capacity of Hayward between Victoria and South Australia. And the capacity of this was progressively released over the quarter, was actually fully released on 11th of April, so after the quarter finished. And on the right here, we have the average time of day flows from Victoria to South Australia on Hayward, which therefore includes the PEC stage 1 flows this quarter. And we can see how the net imports to Victoria reduced during the day. And this is because PEC plays a role in relieving constraints on generation, particularly grid-scale solar generation, that is located in northwest Victoria and southwest New South Wales, by allowing some of this additional energy into South Australia during daytime hours. And this effectively reversed the net flows between Victoria to South Australia in the daylight hours. And on the bottom right, we can see the impact of those flows in the time of day energy prices in Victoria and South Australia, where the South Australian prices are pushed lower than the Victorian prices during those daytime hours. Okay. Now we'll look at the frequency control and ancillary services, or FCAS costs. And the chart on the left shows that we had a significant reduction in FCAS costs this quarter. It was down from 29 million in Q1 2024 down to 13 million this quarter, and with reductions in all regions apart from Tasmania, where the costs stayed pretty much the same year on year. And this reduction is due to both increased competition in the FCAS markets and also because there were no sort of market events in the quarter of the type which would typically increase FCAS prices. And then on the right, we show that batteries continue to be the dominant technology providing FCAS with 59% volume share this quarter. Now, this was actually just a small increase of 7 megawatts average enablement from Q1 2024. The largest increase in enablement we did see this quarter was in the virtual power plants, or VPPs, and that was up 113 megawatts across the contingency services. And that's mainly due to the FCAS availability increasing since Q1 2024. Okay, I was going to pause here for a Q&A, Sleeman, if that works for you.
Yep. Yeah, we do have a few questions.
Okay, cool.
Just take them now. The first question is, what trends are we seeing in the NEM for the use of market interventions, including directions and backstop, to maintain system security in light of the increasing growth of renewable share?
Cool. We do actually show the directions in the QED and the use of directions. Unfortunately, I can't think of the numbers like on top of my head, but we are definitely seeing an increase in directions hours. Like I think there was, I saw some numbers quite recently around the number of directions going back to like 2016, something like 60 a year up to like, hundreds a year now. So we're definitely seeing that increase in directions. Minimum system load events, we didn't have any over the quarter, but now as we come up to spring this year, we are predicting based on the current demand forecast that we will see an increase in those. With, I think, both Victoria and South Australia and possibly also New South Wales having a sort of more than 10% probability of hitting those minimum system load levels at times.
Yeah, thanks, Kerry. I can ask a question quickly.
Yeah.
This is regarding the last slide where you showed the FCAS average prices, and you mentioned there's increased competition in the FCAS market, which is driving the prices a bit low, the decrease. Is this expected as a trend in the future? In I don't know which year exactly the FCAS market will likely saturate. But are you guys expecting a constant sort of trend and decreasing trend in FCAS prices out to, I don't know, 2037 when coal retires?
Well, I mean, I think that as the market transitions, we'll probably see a bit of a sawtooth. So it's even though they're providing 59% of the overall and coal's, well, down to 9%. So, there will be, I would expect some increases as those, increases in costs as those go. But the other thing with the FCAS markets is they can be very volatile. So if you look at Q4 2024 with that big spike in Queensland, that was like just one day effectively that caused that spike where we had a risk of Queensland islanding from the rest of the NEM due to some outages. So, they still will be volatile just because that's the way the market works.
Yeah. We do have another question. Would you like to take it now or wait till the
sure.
end?
We can take it now.
Excellent. So the question is there a specific guideline/NER/framework to manage deals with MSLE events similar to what exists for LOR events?
There is. AEMO has an MSL procedure. I think they're state-based, so there's definitely, I know that there's the Victorian MSL procedure, and it is based on the LOR kind of framework, so that you have the different levels coming up to a forecast event, and then the actions that will be that can be taken. Like the first one is sort of cancelling any planned outages that are impacting exports from the region that's forecast to have the MSL, and then works all the way down to directions to batteries to be ready to to charge during those events. So there is that procedure, those procedures on our website.
Thanks, Kerry. These are all the questions we received so far. I think I'm sure more will come in by the end.
Cool. So we'll go through the NEM generation and then East Coast Gas, and then there can be more questions after that. Excellent. Okay, so these are overall generation outcomes for the NEM. So overall, the NEM generation did increase by 2.2% from Q1 2024 levels, and that was driven by the growth in underlying demand. And we also had some greater supply needs from battery charging and hydro pumping. So the chart on the top left shows those year-on-year changes in average generation. With that increase in the rooftop solar output I discussed, along with increases in grid-scale solar, wind, and then to a lesser extent battery generation. And those increases were partially offset by reductions in black and brown coal and hydro generation and gas-fired generation. So the table underneath that chart shows the changes in each fuel type's contribution to the overall supply mix. And that shows that black and brown coal both reduced their contribution to supply such that the overall share of coal reduced to 53% and renewable share increased up to 43%, which was up from 39% in Q1 2024. And the largest increases driving this was wind, which was up 1.9 percentage point, and then the rooftop or the distributed PV at 1.7%. And the chart on the right shows these same generation changes, but on a time of day basis. And we can see here that the solar generation, both the grid scale and the rooftop PV, it continues to grow across those daytime hours. And this is mainly driven by increased capacity. And then conversely, the black coal and the gas generation decreased in those same hours. And wind generation increased across most hours of the day and or all hours of the day, sorry, and brown coal generation decreased across all hours on average. And then we see that the battery generation is continuing to increase primarily in that evening peak period. And again, that's driven by increased battery capacity. So I'll now work through the various fuel types, starting with coal. And on the chart on the left shows the black coal generation and availability in New South Wales, which is the blue, and then Queensland in the red. And the combined generation and availability across these two regions both reached new lows for Q1. So New South Wales, we had an 8.9% reduction in availability, and that was driven by an increase in capacity on full unit outage, and that was predominantly unplanned outages over the quarter. And generation decreased by 6% with all coal stations in New South Wales, apart from Mount Piper having lower output. And in Queensland, availability actually increased by 4.9%, and that was driven by increased availability from Callide C, which had been offline for all of the previous Q1. But despite this increase in availability, generation decreased by 0.3% with all stations, apart from Callide C, recording lower output. And on the right-hand side, we can see very similar trends in the brown coal-fired generation. So in Q1 2025, generation dropped by 6.7% and availability reduced by 4.9%. And these were both new lows for a Q1. And all of the Victorian power stations contributed to these reductions. And we do also show that the time of day generation for the brown coal on the bottom here, just really showing how that's been reducing in Q1s over the last 4 Q1s. Okay, just quickly look at the gas-fired generation and the hydro generation. So in Q1 2025, the NEM gas-fired generation actually averaged 941 megawatts, and that was an 8% decrease from the previous Q1. And it was also happened to be the lowest level for a Q1 since 2004. And this was driven by a decrease in gas-fired generation in Queensland, which was down 19%. And that was really driven due to the lower demand in Queensland, particularly across the evening peak period. In Victoria, where the operational demand was higher year on year, gas-fired generation increased by 37%. And in the other regions, it was kind of relatively similar to the previous year. And the chart on the right shows the hydro generation, and that averaged 1,248 megawatts across the quarter, down just 7% from Q1 2024. And that was driven by reductions in New South Wales, which was down 22%, and Tasmania, which was down 9%. Okay. So this slide shows the Q1 2025 outcomes for grid-scale solar and wind generation. So the chart on the top left here shows the Q1 trend in the average quarterly generation, and the chart underneath shows the changes from Q1 2024 on a regional basis. So the average grid-scale solar generation actually reached a new all-time high for a quarterly average generation of 2,386 megawatts, and that was 10% higher than the Q1 before. And wind generation averaged 3,517, and that was 18% up from Q1 2024 and was a new high for a Q1. If we look in the year-on-year changes on a regional basis, we can see there was net increases in VER across all regions apart from Tasmania, and wind output increased the most in Victoria, which is up 26%, and grid-scale solar increased the most in New South Wales, up 14%. Now, the charts on the right show these same year-on-year changes in wind and grid-scale solar, but in categories of new capacity, which is any generators which were new since the end of Q1 2024, commissioning, which is any that were sort of undertaking their commissioning or ramping since the end of Q1 2024 and now. Now, the economic offloading refers to when a generator is being dispatched below its maximum availability because some or all of its output was bid into price bands greater than the regional reference price, and so effectively it was undercut by competitors offering their output at a lower price. And then curtailment refers to sort of any remaining limitation on output, for example, due to network constraints. And on the top chart here, we can see that most of the growth in grid-scale solar availability arose from new capacity, and this was primarily in New South Wales and Victoria. There was a small increase in the existing fleet output, and that did have slightly improved availability capacity factors. But these increases were then partially offset by a small increase in curtailment and a larger increase in offloading, which was up 112 megawatts to average 220 megawatts across the quarter. And these increases in offloading were the largest in Queensland and New South Wales, reflecting that sort of more than tripling in negative prices in those regions. And the chart underneath shows a similar pattern for wind availability. So the new and commissioning capacity added 418 megawatts, and there was increases in availability in those sources from all regions apart from Tasmania, but the largest was in Victoria and then New South Wales. Now for wind, the change in existing was 220 megawatts, so larger than we saw in grid-scale solar, and the wind capacity factors increased in all regions apart from Tasmania. Network curtailment actually decreased marginally, but economic offloading grew by 93 megawatts, and that was highest in Victoria and South Australia. Okay, just quickly look at the renewable contribution. So the chart on the left shows the range of renewable contribution, with that shown for the last 5 Q1s. And we can see that the maximum contribution has increased, and that reached 72.4% in Q1 2025, but the minimum contribution has stayed relatively steady, and this reduced slightly this quarter to 13.2%. I think it kind of demonstrates the kind of operational challenges or the flexibility that the operators need to be operating in this environment where the renewables can vary from 13.2 up to 72.4, and that range is growing over time. And then the right-hand chart shows the renewable contribution to the daily maximum operational demand. And because the maximum operational demand typically occurs in the evening, the early evening, we don't have very much contribution from grid scale solar at this time. So it's really from wind and hydro. And we saw that measure increase from 27.6% up to 31.2% this quarter. Okay, so the last for the NEM section will be the grid scale battery outcomes. And on the left-hand side, we have the estimated battery revenue broken up into its various components. And on the right, we have the battery generation and the price spread, where the price spread is calculated as the sort of arbitrage revenue divided by the generation on a megawatt hour basis. So the total battery revenue decreased this quarter by 8% to 44 million, and this was really driven by a 72% decrease in the FCAS revenue due to those lower FCAS prices, which reflect the greater available supply of FCAS capacity, particularly from batteries, as well as a limited number of market events during the quarter. And then the arbitrage revenue increased by 36% to 38.7 million. And that includes so that's making up of the energy revenue, subtracting the energy cost. So the revenue, which is from selling generation, and we also include the revenue here from charging at negative prices, that increased by 44%, and the energy costs increased by 87% up to 9.7 million. So the chart on the right here shows how the battery generation has been growing here in the purple bars, and that was up 86% this quarter to average 98 megawatts. And then the price spread and how that's been changing over time. And the NEM-wide price spread this quarter was $183 per megawatt hour. So that was a 26% reduction year on year. And that reduction really just reflects that lower price volatility that we experienced over this quarter. Okay, so I'll move to the East Coast gas outcomes, and I'll start with the prices and demand. So the domestic gas prices are shown on the chart on the left, and the East Coast gas prices averaged 13.26 gigajoules for the quarter. Sorry, dollars, $13.26 per gigajoule for the quarter, which was higher than quarter one's in 2024's $11.6 per gigajoule, but 25% lower, 2.5% lower, so just a little bit lower than in quarter four, 2024. Now, the price cap that we saw emerge in quarter four 2024 between the Victorian DWGM, or the Declared Wholesale Gas Market in Victoria, and Brisbane, that price separation continued this quarter. So the Victorian DWGM prices averaged $12.18 per gigajoule hour per gigajoule, compared to Brisbane, where the prices were 13.64. And the main reason why these regional price differences occurred was that the supply into the domestic market associated with the LNG projects fell by 8 petajoules, and that led to greater reliance on Victorian supply to meet demand. So we had significantly higher flows into Queensland from the southern markets, and I'll have a little bit more of that on the next slide. And then the international prices, as represented by the ACCC LNG netback price shown here, that increased during the quarter, though it did decrease after the quarter finished in April, with that April decrease due to weaker than expected demand from Queensland and Japanese LNG buyers in the spot market, with a sort of milder than expected winter and some reduced industrial manufacturing demand in those regions. If we look at the chart on the right, the total East Coast gas demand decreased by 2% compared to quarter one 2024, with decreases in all three demand sectors. So the AEMO market demand, or the commercial and industrial and residential demand, fell by -1 petajoules overall, but there was actually a 2 petajoule decrease in the Victorian DWG demand, mainly due to lower commercial and industrial demand. And that was slightly offset by some increase in the short-term STTM market due to a load which had been offline in Q1 2024 being online this quarter. So if we look at the chart on the left, we can see that this is the net supply in from Queensland into the domestic market, and that decreased by 11.8 petajoules compared to Q1 2024. And this was the lowest level we'd seen, the lowest domestic market supply for a Q1 since back in 2017. And this large reduction from Queensland supply to the domestic market, we also saw that in Q4 2024. And this is because the LNG producers use gas swap arrangements to sell more gas to the domestic markets during the peak demand periods, which is in winter, and then they increase purchases of domestically produced gas in other periods to meet their sort of reshaped contracted export commitments. So in other words, the LNG producers are supplying more gas to the domestic market when demand is at its highest, it's sort of May through September, to get the market through those tighter supply demand periods. And then they're getting it back during the lower demand months of October through to April. And then if we look at the chart on the right, so to help meet demand in lieu of that reduced Queensland supply to the domestic market, the Victorian transfers to the other states increased from Q1 2024 levels. And this was really due to an increase in flows to New South Wales, where Victoria exported a net 9.6 petajoules to Kulkarn compared to just 1.5 petajoules in Q1 2024. And this increase in transfers was driven due to increased Victorian production, which was up 14.4 petajoules. And this was driven by high production at the Otway gas plant, which is up 4.4, and Longford, which was up 8.7. So this Longford increase was solely due to less maintenance than due to Q1 2024. And the Otway increase is due to the Enterprise gas field, which commenced production in June 2024, and also the Thylacine West 1 and 2 development wells from October 2024. And that brings the slides to an end, Sleeman. So any Q&A?
Thanks, Kerry. Yeah, we've got a couple of questions. So the first question is, can you explain regarding the distribution wholesale price of $5 to $100 per megawatt hour? What voltage is the custody transfer for the energy? And that's the first part of the question. And the second part, is it high, medium, or low voltage?
Sorry, I'm not quite catching that question. Yeah.
Yeah, it was a bit for me as well. I was just trying to wrap my head around. So let me read it again. Can you explain regarding the distribution wholesale price of 50? So he's providing a range, $50 to $100 per megawatt hour. What voltage is the custody transfer for the energy?
So are we talking, I'm not sure we're talking about the wholesale prices in the NEM here. That's sort of from 59.2 up to 115. These are the NEM wholesale prices. It's not, yeah. So, I mean, it's on the NEM, so it's the wholesale prices from the generation across the, across the whole national electricity market, where we have a combination of the transmission system is 132 kV, 220 kV, 330, or 500. Yes.
Yeah. I mean, the question was the distribution wholesale price. So Mohammed,
well, I don't have the details on the distribution prices.
Yeah, that's why I was a bit confused as well.
Yeah,
right. Okay. So the next question is, what are the forecasts for new generation coming on stream in the near future, and are there corresponding changes in demand?
Yeah, so new generation, we do have a little bit in the QED which does talk about the connections pipeline. So that's the generation in the connections pipeline. So actually in Q1 2025, we did have 0.5 gigawatts of new projects that went through commissioning to reach full output, and a further 2.4 gigawatts that were registered and connected, which will then go through to new, to reach full output. But in the entire pipeline, we have 50.5 gigawatts of new capacity progressing through that process. So there's a substantial amount of new capacity to come on. And then on the demand side, I mean, I would say we look at the ESU demand forecast, which I think the last one was in August 2024, but there will be a new one in this August, in about 3 months. So the overall forecast for NEM demand is to increase over time. Somewhat driven by, just economic things like population and economic growth, but also an electrification of the market over time.
Yep, thanks. Next question is, how are the inertia and system strength dynamics looking with the lower commitment of thermal generation in proportion to IBR/VRE?
Okay. I think, the thing with the inertia and the system strength is they'll have those transition points as the different generators retire. So I think, you have your Lawn and Ararine, and they will, we do have reports that have those levels that come out, and then the transmission businesses are preparing for those step changes with their plans, and I think they're both running they're called regulatory investment tests to choose the best options to help support the inertia and system strength in their networks as those forecast reductions in synchronous generation happens. But I think that, there's definitely forecast reductions in those things, and the transmission businesses and AEMO are looking at solutions to those reductions.
Yeah, thanks, Kerry. We're waiting on a couple of additional questions to come in, so I think maybe.
Which is AEMO has a transition plan for system security. The first one was published in December 2024, and the next, the updated version, and it does talk through those sort of transition points with those reductions in system strength and inertia.
Thanks. A question that just came in now. Can you offer any insight into how incentives might be changed as a result of the NEM review?
The Nelson NEM review. I cannot, I'm afraid. I think the session in Melbourne is on Monday, actually. So I'm hoping to be able to attend that as well. I know that they're looking at, sort of a scheme for when the Commonwealth incentive scheme rolls off, and a new, way to help or support additional generation, and particularly sort of firming or storage and that sort of thing as that goes. But I don't know the details. I'm hoping to be able to attend on Monday.
The next question is, are or can wind generators produce increased inertia?
Oh, it's taken me a little bit to technical. I believe that, sorry. I definitely know that, we're looking at those grid forming inverters on batteries. But I'm not sure about the inverters on the wind farms in the future. Yeah. Sorry.
I guess it depends on how good your forecast is as a wind turbine for upward and downward regulation.
That's a little bit more engineering than me, I'm afraid.
Still waiting on people to reflect and
cool.
formulate their questions.
If there are no more questions from the audience, we might just finish it there. Thanks, Kerry. Oh, I think there's one more actually.
Yeah, one question just arrived. What do you see as the biggest challenges for AEMO in the coming years? Very broad.
Yeah. I mean, I think you could possibly ask everyone in AEMO and you'll get different answers for sure. I mean, to me, there's a couple. One is definitely navigating those kind of transition points as the synchronous generators exit, and just making sure that, you know, that everything is in place to be able to manage those from a system security point of view. So that's probably more for AEMO. I think for the market overall, to me, it's the sort of scale of the build of the renewables and the you know, social license associated with that. You know, it's quite a large build that is coming with both generation and transmission, and you know, that impacts people across the country.
Thank you very much, Kerry. That's been terrific. Actually, I think we've got two more questions.
Cool.
Okay, Slayman, please take.
Yeah. So the question is, are there any network impacts / analysis included in the QED? I guess.
Look, we do include so there's one section we have on the actual interconnectors. So we do look at the performance of the interconnectors and how those flows might change. And sometimes we'll include some constraint analysis in there. And then when we're looking at the overall price drivers, we will sometimes look at the impact of network behavior and network outages in those times, particularly if there was an event that occurred. Those are two aspects we tend to look at.
Yeah, so we've got a reiteration of that question that was asked earlier about distribution wholesale price. And so the question is now, I think, a bit more clear to me.
Cool.
The question is the NEM wholesale electricity cost of, I think they're referring to slide 6, where there was a range of $50 to $100 per
Yep.
megawatt hours. And the question is the average price, average electricity sales price at the point of the power plant? So I think I do understand the question, but I'll let you, Kerry.
Okay, so this
is
is at the regional reference point for each region,
yeah.
So that the power plant will then get that the price from the regional reference price times their marginal loss factor. Yeah.
Yeah. So yeah, the NEM. Yeah, I guess it's regional, not at a nodal level. That's,
No.
I guess.
Yeah, that's right.
So a few questions were about the slides themselves, but I guess the reports are publicly available and published, right, Kerry?
Yeah, that's right. Yeah, it's on our website. Yeah.
Be available on our website in the coming days for the presentation today.
Yeah, let's take one last question, I think, Franca. So has AEMO started considering demand forecasts for AI inference centers? Maybe Kerry, you would know better about this, and how future large baseline loads may be addressed by the market, given the gradual transition and retirement of thermal generation.
Yeah, definitely. I think that it's funny. I was talking to some of our energy forecasters yesterday, and that the work that they put into the forecasts for data centers, which also includes that expected increase from the AI usage. So yes, definitely. And then that will then feed forward into that integrated system plan, which is trying to work out the least cost way to deliver that demand. And that will include like this, the magnitude of demand, but also the expected shape as that baseline goes up, and the combination of the different types of generation to most effectively meet that shape across the day. Yeah, so it's a definite focus.
Thanks, Kerry. I think this is the last question. You just answered now, so Franca, I think we're good to wrap up.
Thank you to Kerry. That's been a marvellous presentation. Thank you to our audience for joining us today, and also to you, Sleeman. We hope to see you next time. Good afternoon.
Thank you very much. See ya.